So we've spent a lot of time reviewing markets and thinking about how to model the economy and did a modeling exercise. Now we come to the point where we actually dive into how we model consumers and consumer behavior. If you think about it, we make all kinds of choices all the time, and we make those choices in all kinds of different ways. So it seems pretty hopeless to try to model how consumers act, how people act actually. So we are all consumers, right? Many of us are also producers. Actually, most of us are both consumers and producers. But we think of consuming behavior separately, right? And by that, we just mean whatever we do, we make all kinds of choices, all kinds of decisions, we do all kinds of things. Whatever we do, we consume a lot. So a lot of our activities can be characterized as consumption. Right now we are consuming. So you're consuming a good that you bought, this education that you're buying. Many of you are consuming the drinks you brought with you. You're consuming the computer you're using. You're consuming the clothing you're wearing. We are all consuming this space and all the technology around here. So, and this is just right now, but of course, whatever you do, you are consuming almost all the time, right? So that's the kind of economy that we live in. Even when you make decisions that don't seem to be market-oriented decisions, like how many children to have, which is what we talked about last class, even then you're actually engaging in economic choices very much. So how do we model that kind of choice? That's the question. And it seems pretty hopeless because it's such a variety of choices and settings. But we take a very general approach. And the general approach is we think of people as engaging in goal-oriented behavior. So we don't go much deeper than that in making assumptions, but we make that assumption, that people engage in goal-oriented behavior. That means they have something in mind that they want, and they are working towards that goal, whatever that is. As they do that, they face various constraints. So these are, in a way, barriers that stand between them and their goals. So that's the view we take. What that goal is really pretty open, and what it might be. You might be, your goal doesn't have to be increase my personal profits. It doesn't have to be like that at all. It can be lots of things, as you will see. But you're engaged in some kind of goal-oriented behavior, and you're facing constraints as you do that. So this is basically our assumption about consumer behavior. And that goal-oriented behavior, the goal side, is characterized by preferences and the utility function. And the constraint side is, for the most part, what we call the budget constraint. So if we understand how we model preferences and utility and then the budget constraint, that basically gives us our theory of the consumer and of consumer behavior. Put those two together and you get optimal choice. So the consumer's optimal choice is maximizing utility subject to the budget constraint, basically. That's where we want to get by the end of the class today. And then, of course, from that optimal choice, we get the demand curve, right? That's where we started. We started with, do we understand the demand curve? Well, we understand it a little bit, but now we will really understand it. We will understand exactly where it comes from. Okay. So, preferences first. We'll talk about preferences, we'll talk about the budget, then we'll put the two together, and that'll be today. So, preferences. What we mean by preferences is simply what you like. And that doesn't have to be, like what kind of pen or what kind of drink, although that's definitely part of it. And many of our examples will be like that because it's simpler to think about those kinds of examples. But it could be, do you like to save money for the future? Or do you like to have a lot of time for yourself to go hiking, as opposed to spend your time making a lot of money? those are choices too, and those will be characterized by your preferences. So preferences are not necessarily over very simple goods that we think of, but often our examples will be like that. So how could we find out someone's preferences? And this seems really, really difficult. So I'm wondering what your thoughts are on that. How can we find out what your preferences are, for instance? There are at least a couple of ways. Yes?
You ask or experiment?
So you could ask. You could simply ask. Like here in my example, I put 2 bundles here, and of course these are very simple bundles, but we have to work with simple bundles when we think about our models at first, right? So if you have a T-shirt and 2 music albums and a pizza, right? That could be one bundle, and 4 albums and pizza could be the other bundle. And then we could just ask you, which one do you prefer? And you could say, I prefer the one with the T-shirt and 2 albums and pizza. So now we have one piece of information about your preferences, right? That's definitely part of your preferences, definitely a tiny, tiny, tiny part, right? But we could ask lots of questions like that. We could just ask a zillion questions like that, and we would start learning about your preferences. So we could do that. Okay. It would be very difficult. What might be another way to learn about your preferences, Bjorn?
You could look at the decisions that people end up making, and then sort of like the way they reveal their preferences.
Okay, yeah, sure. So you could, instead of asking them about hypothetical choices, you could actually look at what choices they do make. That would have the advantage of not asking a bunch of questions that may not be relevant ever, right? Because we will end up asking about lots of bundles that will never arise somehow. But so it has that advantage. It also would be less complete as information. Yes, Brianna.
And kind of adding on to that, looking at what they spend the most money on.
What they spend the most money on. Yeah, so that would be along the lines that Bjorn says. We would look at their consumption choices. Mm-hmm. So those 2 would be, one would be surveys, right? That's the first approach. And surveys about your preferences, not your behavior. But the second approach would be actually looking at your behavior. So what do you consume? And we would assume that those choices reflect your preferences somehow. So what would that look like? Something like we would meet you just outside a grocery store and look at what you bought and then calculate how much it cost. So we see you coming out of the grocery store with $150 worth of groceries, and we take a look at what that is. One thing we can probably conclude is that other baskets of goods that also cost $150 or less would be less preferred than the one you walked out with. That would be how we would do that, right? So we would think you're a person who is goal-oriented, trying to maximize your own happiness or your family's or whatever your goal is, right? And the budget constraint is what keeps you from perhaps getting more or other kinds of groceries. So we look at that constraint. It's $150. We will assume. And whatever else you could have bought for that money, we think is probably less preferred by you. And that would be information about your preferences. So that approach is sometimes called revealed preference approach, because you reveal through your choices what your preferences are. Okay, so one way or another, we could get this kind of information. Now, if you think about these bundles, how many goods are there in the economy that are relevant for the average person? I mean, thousands is probably right. So there's a lot. Of course, either one of these approaches would be very complicated. That's one thing you need to keep in mind. When we do this model of the consumer, it's not that we imagine that we are going to gather preference information about everyone in the economy and then create one big model of the economy that way. that's not really true because that would be pretty unrealistic, is that we want to be able to model how consumers make choices so that we can, in general, make predictions about the effects of various policies, for example, or understand how markets really work. We want to get insight from this kind of theory. It's not that we imagine that we will one day have many, many thousands of goods and everyone's preference is in a computer. I mean, I don't know if anyone's thinking that. I kind of hope not. But that's not what we are thinking, right? We are just thinking about how do we build a model that will allow us to get insight into how the economy works. So we will start with the simplest possible case, pretty much. I guess the simplest would be having one good. Maybe that's the simplest, but not interesting at all. So the simplest that is interesting, and that would be two goods. And in much of what follows, we're going to look at basically two goods, consumption choices over two goods, and an economy with two goods. And you should just keep in mind, I know this is difficult because we'll get caught up in these two good exercises. You should keep in mind that what we have in mind is an economy with many goods. And if you were to go on and study economics in graduate school, in your first year microeconomic theory course, you would have many goods. So you would have some unspecified number n of goods in the economy, and you would do the same thing that we are doing in a much more abstract model with n goods. And that's entirely possible, and the insights we get from two goods very often carry over to the more general cases with many, many goods. Okay, so let's dive right into it. The two goods for today are going to be noodles and tea. And I put those on the two axes. You might ask, well, don't we need units? And as I've said before, we are a little careless with units in economics. But we really should think about that. So if that bothers you, you can add some units there. You can add ounces of noodles or bowls, or you can have cups of tea or whatever you want. So you can, there are units. We are talking about quantities. But we usually don't bother to talk a lot about units because they are not the focus of our attention in this. But we're talking about quantities of noodles and tea. And the reason I put that graph, I put those two axes down, is that we can basically model any bundle consisting of these two goods as a point in the plane. So this point A is a combination of some number of units of noodles, right there. That's how many. And similarly, it's also some quantity of tea, right there. For B, again, that's some quantity of tea, and it's some quantity of noodles. And every single point in the plane is a different quantity of noodles and tea, a different combination, a different bundle. So the advantage of this kind of representation is that every possible bundle of noodles and tea is represented here somewhere. We are thinking just positive quantities, and so we are thinking about just this quadrant. But in principle, maybe you could have negative quantity of something, like you could owe goods, right? But for now, we'll think about just this positive quadrant. So if we had three goods, what would that look like? Yes? Go ahead.
Just I don't know how to say.
Oh, you're showing me. He's showing that. That would be like 3 dimensions,
Yeah,
right?
3 dimensions, yeah.
That would be all the points in 3 dimensions. That would be all the bundles of 3 goods. And if we had 4 goods, that would be 4 dimensions. And I can't imagine that, but you can, at least you can write it down. You can write it down as a vector. So I'm just saying, this is 2 goods. Graphically, this is easy. Of course, we wouldn't use a graphical approach with more than 2 goods. That's another reason we use the 2 good example, because we can see graphically really well what's happening. And those insights actually carry over to more goods as well. So this plane here represents all possible bundles of these 2 goods. And now we need to figure out how we represent preferences over all those bundles. So by preferences, we mean like maybe point B is preferred to point A. So that would be saying this bundle for this particular consumer is better than that bundle. What do you think about point A and C? Which one would be preferred? Would C be preferred or A? C? And why do you say that? Yeah, so C, if you look at C, it has more T, right? More on this axis, more, and more noodles, so it's more of both. So if we assume that these goods are liked by this consumer, so these are actually goods as opposed to bads, then C would be preferred to A by this consumer. That is called monotonicity. So monotonicity simply means more is better. And it's a property that preferences can have, someone's preferences. Okay, now let me ask you this question. If I know that B is preferred to A by this consumer, and well, I guess we already know that. I'm going to change this, maybe. Let's say it's the other way around. A is preferred to B. Okay? So if we know that this consumer prefers A to B, and we just said that C is preferred to A, can you tell me anything about C and B? What is that? So what you're saying is C has less tea and more noodles, which is true. That's a true statement. My question is, if I tell you that this consumer prefers A to B, and we know that because of monotonicity also prefers C to A, is there anything, Dan, that you can tell me about C and B?
Is it that shot in the dark again? Is it that the person more strongly prefers noodles than tea?
Maybe I'm looking for something a little different. Go ahead.
C is preferred over B.
Why do you say that?
Why?
Yeah.
Because there's more noodles, and B, A is preferred over B, so T is not very, I don't know, desired. So C would be preferred over B.
You feel it would be. So I would agree, but I think maybe there's a better justification for saying that. Kazuma, do you want to try?
Yeah. So the first question is whether or not you can only pick one of those 3 points. If you can only pick one of those 3 points, then it's possible that he just likes noodles, and so the more noodles, the better, and he's just getting the extra tea. If you can pick any point and he still prefers C over B, then one possibility is he likes more noodles, but he doesn't think he's going to drink that much tea, and he doesn't like to waste tea.
He likes both.
He likes both.
Let's say he likes both. Yeah, Zach.
Since we know that C is preferred to A, and I'm trying to imagine, like, without restating. Because C is preferred to A and A is preferred over B, we can infer that C is preferred over B.
Okay, so your suggestion is C is preferred to A is preferred to B. We're going down preference, right?
Mm-hmm.
That's your feeling. So we are going from the more preferred to the less preferred. We go from C to A, less preferred, from A to B, less preferred. So then that B must be less preferred than C, right? So your reasoning is, if we go from the more preferred to the less preferred, we end up with the less preferred, right? It seems kind of, maybe it seems obvious.
That graph says that, I thought all that it says is that B is referred to A and C is referred to A.
So right now it says C is preferred to A and A is preferred to B.
Oh.
Okay. Which should mean that C should be preferred to B. Okay, so we should be able to conclude that C would be preferred to B. That is called transitivity. So that property is called transitivity, and it simply says that if C is preferred to A and A is preferred to B, then C must be preferred to B. Okay? So you could imagine that someone might not someone's preferences might not satisfy that property. You could imagine that. But it would be a little weird, right? And the argument that economists would sometimes give for assuming that preferences are transitive, which we assume, so we assume that preferences are transitive, and the argument, the justification we sometimes give is something like this. If you had 3 soft drinks in front of you, like Nestea and Sprite and Coke, and you had preferences that are not transitive, that would mean, you know, I would ask you, do you prefer Sprite to Coke? And you would say yes. And do you prefer Coke to Nestea? Yes. And do you prefer Nestea to Sprite? Yes. That would be circular, right? Mm-hmm. I could say, okay, here's a Sprite. Oh, wait. You like Nestea better, right? Yeah. Okay, pay me 10 cents, I'll give you a Nestea. Here's a Nestea. Okay, oh, wait, before you drink that, you like Coke better, right? Yes. Okay, give me 10 cents, I'll give you a Coke. Oh, wait, before you drink that, you like Sprite better, right? Yes. Give me 10 cents, I'll give you a Sprite.
You're going to charge him every time?
Yeah, every time. You could go on forever like that, right?
No.
That person would be willing to trade every time because they like the next one better, but their preferences are circular. So one justification we give for saying, you know, people probably wouldn't have intransitive preferences is if they did, you could take advantage of them pretty easily. Yeah.
Is the technical term for those kind of people suckers?
Maybe it is, yeah. So, transitivity, monotonicity, we will assume both for the most part. Completeness just means that, Kazuma, this relates to your earlier point, it means that we can compare any 2 bundles. So when we say your preferences are complete, what we mean is I could give you any 2 points here in this plane, and you should be able to tell me which one is preferred to the other. And sometimes it's easy because by monotonicity you can say more is better, but sometimes like between A and B it's not clear which one would be preferred. But you should be able to tell me no matter what. Now, is that a realistic assumption? Probably not. I mean, we don't think about all possible bundles, right? You would have, that's a lot of mental effort to think about all possible bundles that you could consume and what your preferences would be. We don't do that. In our models, in our basic models, we assume that. You wouldn't have to. So there are other kinds of models that don't assume that. That would be a little more complicated. So that's our basic notion of preferences. We have all those points. We need to indicate, you know, what's preferred to what. And there's a really, really simple and intuitive graphical way of doing that, and that's using indifference curves. So I can show you what your preferences look like in the plane by just drawing a bunch of points that are indifferent to each other. Like those are all indifferent to C, these are all indifferent to B, and these are all indifferent to A. And I can tell you that your preferences would be increasing in this direction. And the higher you go on those indifference curves, the better. So that way I can show you graphically what your preferences look like. I can represent all your preferences pretty easily. Otherwise, you could see how this would be a big mess. Did you have a question, Umer?
Yeah. Can you explain the completeness property again?
Okay, yes. So completeness for preferences means that for any 2 bundles, you can say which one you prefer. So incompleteness would mean sometimes, you know, I would ask you, which one of these 2 bundles do you prefer? And you would say, well, I don't know. I don't know.
Can this property be a part of completeness as well, like the more the better?
Say that again.
For instance, like I'm a person who says that the more the better. That helps you make my
That helps you, yeah.
That can be part of completeness.
So, but your point is, if your preferences satisfy monotonicity, then they are complete for bundles that can be compared in that way. But still, you could have 2 bundles such that neither one is more in everything, and so you might not be able to compare them, right? Okay, so completeness and monotonicity may be somewhat related. Monotonicity gives you a certain level of completeness, maybe. But it doesn't have to mean that your preferences are complete in the sense that you can compare everything, any 2 bundles. Okay, so we represent your preferences using this graphical device, which is called indifference curves. And every one of these is an indifference curve. So this would be an indifference curve. This is an indifference curve. This is an indifference curve. How many do you have? How many do you have? What was that, Dan?
Theoretically infinite.
Infinitely many. You have infinitely many, right? So I drew 4 right here. We only draw finitely many. I usually only draw finitely many. But you actually have infinitely many, right? I could pick any single point, and that's a bundle, and I could draw an indifference curve through it. Okay. So the shape of these indifference curves tells you a lot about preferences, and that's why it's very useful. This, for example, if I draw this, you can tell that C is preferred to B because it's on a higher indifference curve, right? If I were to give you two other points, like these two, this is D and this is F. Which one is preferred?
D.
And you know that because there is an indifference curve separating them, right? So that means if I were to draw one through D, it would have to stay on the right of the one through C. So it would be somewhere here. If I drew the indifference curve through F, it would be somewhere below that indifference curve through C. So therefore, the indifference curve through D is higher than the one through F. And we know that because indifference curves can never cross. Do you understand why? Do you understand what it would mean if two indifference curves were to cross? You know, if I were to draw another indifference curve and it went, I don't know.
Well, it would mean that it wasn't running parallel to it.
It would mean like it's like this, right? So through that point C, there are two indifference curves now. What does that mean?
It takes away the monotonicity.
Well, it's not even that. It's more basic than that, Adrian.
I was going to say, it will mean you have incomplete preferences.
No. Not, it's worse than that, Alexander.
Is that a correlation between the two?
Between which two? Yeah, okay. We can't tell which one is better, right? So if you look on the right, on the right of C, the blue one is above the black one, but on the left, the blue one is below the black one, and yet all the points on that blue indifference curve are supposed to be indifferent. So what's the deal? You know, those are all points indifferent to C. The ones on the black indifference curve are indifferent to C. That doesn't make any sense. And then C would be better than itself, and things like that. So what that means is we can never have that. Two indifference curves never cross. Yeah, Ryan.
Can we ever have an indifference curve that goes the other way?
What would that mean? Well, that's interesting. So we actually get to that. Why not? I mean, we could, right? We could. That would be that. What you're saying is, I love it because what you're doing is you're thinking about the different shapes of these indifference curves, and thinking about what that would mean, right? So that's where we want to go. We want to be able to look at an indifference map like this, and draw conclusions about your preferences, and the other way around. If I tell you something about preferences, you should be able to represent those preferences graphically using these indifference maps. So we'll get back to that, but let's practice a little bit, okay, with maybe simpler ideas. Here's an indifference map. What can you tell me about noodles and tea for this consumer? Remember, this is always for one particular consumer. So we are talking about someone's preferences. What can you say about this person's preferences?
They both value noodles and tea equally. Or they value both noodles and tea the same.
Value noodles and tea the same. What do you mean by that?
Because the slope is 1 to 1. They value 1 unit of noodles the same as 1 unit of tea.
Okay, so Jim is saying this consumer values 1 unit of noodles the same as 1 unit of tea. Another way to say that would be if I were to ask you to give up 1 unit, 1 cup of tea, how many cups of noodles would you want instead? 1. That trade-off would be 1 to 1. So if I were to say you're at this bundle right here, and I'm going to take away 1 unit of t from you, I need to give you 1 unit of noodles to make you indifferent to where you were before. Yes, Fanita? I'm sorry, can you speak up a little bit?
I don't understand where you get that the slope is 1.
So this, the slope is, we can say it's 1, although I don't have any units on here, right? So maybe that's your point. This is a little sloppy. We can definitely say that the trade-off is the same at every point, right? That was your comment too? Okay, okay, very good. So what we can say is, if I ask you, I'm going to, like you're right here, let's say, I'm going to take away 1 unit of t. So now you're here. What do I need to give you to make you indifferent to where you were? I need to give you this much noodles, and now you're indifferent. Well, if we now say you have a completely different bundle right here, and again I take away 1 unit of t, what do I need to give you to make you indifferent to where you were before? Again, the same quantity of noodles exactly. So if the slope is in fact 1, then it will be 1 cup of tea for 1 cup of noodles. That trade-off is the same everywhere for you. So that's what we can say based on this indifference curve. So basically you care about how many cups of tea and how many cups of noodles you have, and we might as well add up the two because the trade-off between those two is 1 to 1. You could have 4 cups of tea and 5 cups of noodles, or you could have 3 cups of tea and 6 cups of noodles, and that would be just as good. We can trade off the two. In fact, we can go to extremes. If this right here, let's say is 10, and that intercept is also 10, and now that I have units on here, now we can say the slope is 1, right? If that's true, we can say you're indifferent between having 10 cups of noodles and 10 cups of tea. We could say that. Yes, that.
So when it's when the curves are instead concave as opposed to linear, with optimization, when it's convex, and we call it diminishing returns, what we call it in this case, where the trade-offs are not the same.
We'll get to that. So what this says, you're pointing out what this says is, in the previous picture, the indifference curves were kind of concave or convex maybe. They were convex. I'm going to call it convex.
Okay.
That, of course, would mean that the trade-off between the two goods is not the same everywhere, right? What does that mean? Well, we'll get to that. So that's interesting. That's an interesting question. Okay, so that's one fairly simple case. Let's look at this one. A little different. What can you say about this person's preferences between noodles and tea? This is more complicated. So if you want to, we can put some units on here. Maybe that will help. Let's say this is 5. That's 5. That's 3. 3. 1. 1. Think about that for a moment. What can you tell me about this person's preferences about noodles and tea? In English. So don't just describe what the picture says, but in English. What can you say? I'll give you a minute, okay? Okay. So Ryan, what do you think?
It almost doesn't make sense because there's a difference between getting 5 noodles 5 tea and 5 noodles 10 tea. That doesn't really follow monotonicity.
That's a correct statement. What does it mean? Yes, Celia.
Doesn't it mean that they don't really want a variation of goods? They want like all the same good?
What do you mean by they want all the same good?
So if they're for any point on any of the indifference curves, like for any amount of noodles, they don't really care how much tea they have.
Is that true that for any amount of noodles they don't care how much tea they have? Is that true? That's not true. Like look at 5. You know, right here, that's 5 cups of noodles. Do they care how much tea they have? Oh, yes. Yeah, because 3 is better than 1, and 5 is better than 3. Beyond 5, they don't care. Up to 5, they care, right? What does that mean? Yes, Bjorn.
Do the goods like interact with each other in a certain way that you need like a ratio, or like at least a certain ratio of them, and beyond that or below that, they're not really useful?
And what's the ratio?
1 to 1.
1 to 1. Yeah, that's what it means. It means this person has noodles with tea, and that's it. 1 cup of noodles with 1 cup of tea, and that's how this person likes it. And if you give her 3 cups of tea and 10 cups of noodles, those 7 cups beyond the 3 of noodles are completely useless. It doesn't matter because there's no tea with it, right? So this person has noodles with tea 1 to 1, and that's the only way. That's what it means. Yeah.
Doesn't that break monotonicity?
Does it violate monotonicity?
Yeah.
Yes, it does. Yeah, so these preferences don't satisfy monotonicity unless what you mean is you give more of both things. So this person will still like more of everything together, but will not care for more of just one thing necessarily. Okay? That's what it means. Yeah, Zach.
So if we define the good as the, whatever you call it, breakfast of noodles and tea, and we say that was a good, we draw out like a different, then it would not violate monotonicity.
Yeah, that's right.
'Cause it
You would like to redefine these goods for this consumer. Yeah, you could, but I would not go there.
Okay.
However, there's a name for this in economics. You've probably encountered it in intro. What would these 2 goods be called? Yeah.
Complementary.
They are perfect complements, right? So these 2 are perfect complements. They are consumed only together by this consumer. Now that we mentioned that, in the previous picture, what did we have?
Substitutes.
These are perfect substitutes, right? You can trade off noodles and tea 1 to 1, and it doesn't matter. In this picture, we have perfect complements, so you only consume these 2 together. Okay, so see what I mean? You can say a lot about preferences looking at these indifference maps and going back and forth. Okay, so let's do a little more, and then we'll try to put this together. We'll talk about the constraint side and try to put the 2 together. So what can you tell me based on this picture about the preferences between noodles and tea for this consumer? So what I changed here, again, there are no units, but what I changed here is these indifference curves are more flat. Okay? What would that mean? Think about it. Yes, Anya.
I'm working with my hands.
Oh, I thought you were raising your hands. Okay. Well, if you have a thought, then let us know. So what do you think? Maybe I'll wait a little bit. I'd like all of you to think about it. It has to do with what? You should all be able to answer this question. It has to do with, Maddie?
So looking at the slope, you can see that it's not 1 to 1, it's more of a fraction, and so that would show that T is more preferred to more.
Okay, so you're looking, what you're saying is, it has to do with the trade-off between noodles and tea, and what you're saying is, this consumer seems to like tea more. Okay, so do you agree with that? Think about it. Do you agree or disagree? You disagree. Why do you disagree? Maybe someone, yeah, Naman.
Because if you take, so if you take 2 tea bags out of a person, 2 tea bags from a person, we'll only have to like.
So we are here.
To reach the line again.
So we take away 2 units of tea, 2 cups of tea,
Yeah.
and then to make them indifferent,
We need to give them one noodle.
we need to give a little bit of noodles. Is that what you're saying?
Yeah.
Okay. What do you think? Yeah, Theo?
It seems like this person is most happy when they have an equal number of noodles and tea, and then if you try and give them more noodles and exchange that for tea, they have some type of diminishing marginal return, so they don't value those noodles quite as much as they did before in relation to tea.
So I think you may be attributing too much to my artwork here. If we just think about this slope, as Maddie just did and Nauman just did, you can look at the same thing in a slightly different way like this. Suppose you're at this point. This consumer is consuming this bundle, right? That's what it means, a certain number of cups of noodles, cups of tea. If we wanted to move this person to this next indifference curve, I shouldn't even say that. There is no such thing as the next indifference curve, right? Because there are infinitely many. Like the next one is infinitely close to it. Okay, but on this picture, the next one I drew, if I wanted to move that person up to that indifference curve, how much noodles would I have to give her? This much, that much. How much tea? This much. So I would have to give a lot more tea, which means what brings more happiness to this person? Noodles, right? Okay, so just from the slope of these indifference curves, now we can say this person seems to like noodles more than tea, compared to someone with a different kind of indifference map, which might look like this, right? So now this is an easy question. What can we say about this person's preferences?
Likes tea more.
Yeah, likes tea more than noodles, okay? All right, so do you have any questions? Yes?
So what's the difference between like movement? I don't know if I'm just confusing two different concepts here, but like movement along the indifference curve versus movement to a new indifference curve.
So along an indifference curve, all the bundles are indifferent, and that's it. There's nothing more and nothing less to it. That's all. If you move to a higher indifference curve, all those bundles will be preferred.
Oh, I see.
That's all. Nothing more. Yeah, Bjorn.
It seems like for certain purposes it would make a lot of sense to measure the noodles and the tea in the physical amounts to see which one somebody prefers, but in other cases it might be useful to measure them in the amount that like a given dollar could buy. And so it kind of like the units do matter if we're gonna like make any inferences from the slope, right? Because if you're measuring noodles in tons, but tea in fluid ounces or something like that.
The units do matter in that you need to be consistent when you talk about prices. So if I in a minute we'll talk about prices. When we talk about prices, those should be per the same unit. Okay? So that's important. So when we talk about the price of tea and the price of noodles, if we are graphing this for cups of noodles and tea, those prices should be dollars per cup of tea and dollars per cup of noodles. Yes?
In the second graph, where it's like perfectly complements.
This one?
Yes.
Okay.
So that can be, the green line can also be vertical, right?
Yeah. I'm just showing that the higher, so these indifference curves are higher than these and higher than these. That's all. Yeah. Okay. So let's get back to, before we talk about the budget constraint, let's get back to that first question that I forget who brought it up. Maybe Ryan brought it up or maybe Dan brought it up. So someone brought it up when we talked about the perfect substitutes. What does it mean for this kind of indifference curve? And by the way, this shape of indifference curve that I'm showing right here is pretty much what we normally would use. So this seems like a kind of a standard indifference curve for standard preferences, if you will. So we'll talk more about that. You'll see more of that. But it's not linear. So we already know that that has something to do with the trade-off between these two goods. And now we know that that trade-off is not the same at every point, at every bundle, for this type of indifference curve, for this indifference map. What can we say about this shape of these preferences based on the shape of this indifference curve. So what can we say about that trade-off? That we know it changes. What can we say about it more specifically? So my graph is helping you a little bit. There's a bit of a hint there. Yeah, Jimmy.
So the more extreme you get, the less you value each good. So if you have, so at the middle you probably value them equally. So 5 and 5 would be about equal, but at like 10T, you would probably trade like a lot more to get just one noodle than at 5T.
Very good, very good. So what you're saying is in the middle, if we looked right there in the middle, the slope, that seems like a slope of 1 or so. So that at that point, we would be back to that 1-to-1 trade-off. But when we get more extreme, so what does extreme mean? Extreme means right here, right there, we have very little T and a lot of noodles. So what do you think? What is our value of T and noodles based on what you just said?
Our value of T is a lot lower than our value of noodles.
I don't think so. I think that contradicts what you just said earlier. So at this point up here, we have a lot of noodles, very little T.
Yeah, our value of T is a lot higher than our value.
And you would value T a lot more at this point than noodles. So what that means is, if I ask you to give up 1 unit of noodles, so 1 cup of noodles, how much T do I need to give you to keep you indifferent? And the answer is very little. And the difference between these 2 points in terms of T is tiny, right? So I can just give you a ½ an ounce of T and take away a cup of noodles at that point, and you'll be happy. But down here, you have little noodles and a lot more T. At that point, if I ask you to give up 1 more cup of noodles, and you'll have even less noodles, I need to give you a lot of T to keep you indifferent. Because at this point, you have very little noodles and a lot of T, and therefore you value noodles a lot more than T. While up here, you value noodles a lot less, because you have a lot and you have very little T. Okay, so this shape of indifference curve tells us something about the trade-off between those two. And in particular, it tells us about the marginal value of these 2 goods. So what we are looking at here in this exercise is actually the marginal value of noodles when you have a lot of noodles versus when you have a little noodles. And the marginal value, marginal just means 1 extra unit. That's marginal. So at the margin, we say that in economics a lot, meaning at the very last unit. So up here, what's the value of that very last unit of noodles in terms of T? And that's important. Not in some abstract way, but in terms of T. What's the value of that very last unit of noodles, that last cup? Not much. The marginal value of noodles in T is pretty low. Down here, that last cup of noodles, so this one that I'm taking away, what's the value of that in terms of T? It's a lot, very high. So the marginal value of noodles goes from low to high as you move down this indifference curve. Okay? So that's an important concept, the marginal value in terms of T, because it tells us about what that good is worth to you. In a 2-good economy, you can care only about 2 things. So here, you can only care about noodles and T. So when we ask, what is noodles worth to you, the only way that question makes sense is if we ask, what is it worth to you in terms of T? Okay. Question, anyone? Half a question. Okay. We'll wait. Okay.
I just wasn't sure if you were going to get to it.
So I'm not sure either.
Is there a term for that sort of behavior?
So we could say that your marginal value of noodles in T is diminishing.
Okay,
yeah, as you have more noodles. Okay, so I think we've explored the preference side of this quite a bit. Now, the good news is that the budget side is much easier. This is really, really straightforward stuff. we are using the same axes, so we are working in the same picture. Okay, but now we ask, how can we represent graphically those bundles that are available to you given your income? So you have some level of income. We usually denote it by capital I, so that will be your income. Let's say it's 100, and the units are dollars. We don't usually write that either, but what we have in mind is we just say dollars. Okay. So you have a certain level of income. How can we represent the points that are affordable to you given that level of income? And this is really pretty straightforward. Like, how would I find this point? You tell me. That is the amount of noodles that I could buy if I spent all my income on noodles. How would I find the value of that point?
Use the income to over the price for each noodles.
I would take the income I have, $100, and divide it by the price of noodles. So if the price of noodles is 10, this would be 10. Okay. How would I find this point? Same way, right? So I could take my income and divide it by the price of tea. And if the price of tea is 20, then this would be 5.
So the slope is show us about how much difference between the price for two objects.
Now the slope, I drew a straight line between the two, right? And I'm going to ask you that question. Why did I do that? Why is that a straight line? I mean, I'm claiming that if you can afford this bundle, 10 cups of noodles, and this one, 5 cups of tea, I'm claiming you can afford anything in between on that straight line. How do I know that? But wait. Let's give everyone a moment. So think about it. Think about it for a moment. How do I know that? In fact, what would be really helpful for you at this point is if you actually wrote down the equation that characterizes that line. If you could write down the equation of that line, that would really help you. So give it a try. Okay, raise your hand if you have the equation. Okay, good. So I'm going to ask you just for 1 minute. Those of you, I think at every table we have someone. If you have the equation, share it with the others, okay? Right now. 1 minute.
But you can just do the basic y equals mx, and then the slope is a negative slope, it's going downwards, and then the b is the intercept of the y. So it's 10.
Okay. Let's say someone from that table back there. Tell us your equation.
Y equals negative 2x plus 10.
Negative 2. I understand. You actually used... Okay, so let's start with that. So first of all, we have n and t, right? So n, you're saying n equals 10 minus 2t. Is that, am I right? Yeah? Okay. So that's using the actual numbers that I gave you. So that's a good start. Let's use now, instead of 10 and 5, let's use I and Pn and Pt. How would that go?
Y equal to negative, y equal to
So n equals to?
Yeah, n equals to negative price of tea over price of noodles time T minus income over price of T.
So we know what the intercept is. Okay, that's the I over Pn, that's the intercept, so we know that. But what you also calculated is the slope of this line. What's the slope of this line?
Price of T over price of N.
So why is the slope Pt over Pn? You're right, I mean that's the slope, but if you didn't get that right away, think about that for a moment. Why is that true? Because it's not true. What are we missing?
Negative.
It's a negative slope, right? So we should really say negative Pt over Pn. What is slope? Rise over run. Okay, so what is, in this case, rise is a fall, so it's negative I over Pn, that's the rise, divided by I over Pt. That's the run. And if the i's cancel out, and you just are left with negative Pt over Pn. That's the slope, right? Okay, so the equation would be n equals, the intercept is I divided by Pn. The slope is minus Pt over Pn times T. That would be the equation. That doesn't look too interesting. But if you rearrange it a bit, it would look more interesting. Can you rearrange it in a way that makes it more interesting? What would you do? That's what I want to hear. I'd like to hear more of that. What happens when you rearrange it? Take a look. Think about it.
So it's almost like.
So Chang, what do you get?
So like I minus T plus PT over P.
What would you do to rearrange it?
We can just LCM.
What is that?
LCM.
I would multiply it by Pn, right? Both, the whole thing. So what do we get? Pn times n equals I minus Pt times T. And now let's add Pt times T to both sides, and we get I equals Pn times n plus Pt times T. Why does that make a lot of sense? Who can tell me? Why is that now suddenly really interesting? Yeah.
So that is about this equation is almost like to show about your money what you get and how many noodles and how many teas you can just use your money to.
It exactly describes mathematically what budget constraint means. The very meaning of budget constraint, right? This is your income on the left. That's how much money you have. Pn times n is how much you spend on noodles. Price times how much you buy. Pt times T is how much you spend on tea. Price times how much you buy. You add up the two, that's your expenditures. Your expenditures should equal your income. That's it. Makes a lot of sense, right? So that's the budget equation. And that red line, that's the budget equation, graphed.
Also, we're assuming that all the money is being spent.
We are. So when you look at that red line, when we graph that red line, that is all the money being spent. Exactly right. Exactly right. So when we look at what can you buy, well, you can buy anything on that red line. You can also buy anything in that shaded green area. All of that will cost less than 100 in this case, right? So our model of the budget constraint is really straightforward. It's just this equation that says your expenditures must equal your income or be less. And we just graph that line. Okay. All right. So any questions about that? Yes.
I still don't understand what is the means for that slope. I mean, what is the means about the negative price of T over price of N? Do you have some meaning or definition for that?
The question is, what's the meaning of that slope? That's the ratio of the prices, right? The slope is the ratio of the prices of the two goods, and that's all it means.
So that means about how value to exchange from the one object to another object?
Well, let me ask you this way. What does it mean if the price of, like in this case, I just gave you an example. What does it mean if the price of noodles is 10 and the price of tea is 20? Just tell me what it means. It's not complicated, nothing fancy. What does that mean?
So that means if you use the same price to get the tea, you can get the double noodles.
Yeah, that's what it means. So it means for $20, you can either get 1 cup of tea or 2 cups of noodles. That's what it means.
So
Nothing more and nothing less. Yeah.
to make the value to be equal.
Okay, so that will be important when you make a choice, right? So let's look at how that would work. Let's try to put these two together. Okay, so we have these two models. We have preferences on the lower picture. We have the budget constraint on this picture. And if we put the two together, we should have our model of the consumer, right? Okay, so there it is. That's the model of the consumer, right there. Now, take a look at that picture. It's beautiful, isn't it? Take a look at it. What can we say about this consumer's maximization problem? Just take a look and tell me what you can say. Which point would this person choose? What bundle of noodles and tea would this person choose? Brianna, what do you think?
A. Because they can't get B or C.
So if you were to look at just A, B, and C, then A is the only one that's affordable. True. If you looked at all the points, the whole infinity of bundles in this picture, which one would this consumer choose?
Well, the budget constraint is kind of like tangent on the B. So there are some bundles on the B indifferent curve.
Right there?
Yeah.
Right there, the budget constraint is tangent to an indifference curve. Why is that important? So, by the way, so Harry, are you saying that the consumer would choose that?
Yes.
Okay, so let's mark that point. And let's say that point is X. Why is that an optimal choice? I'll wait for all of you to figure it out. You know this. I know you know this. Adrian?
Because it's within their means, and it's also like at the point at which they get their optimal number of mobility.
It's within their means, so that's very important. It's on the budget line. It's within their means. But that doesn't mean it's the best thing within their means yet. Austin? So I understand. How do we know that she's maximizing right there?
She's giving up a little bit of noodles to get more tea.
What would it mean to do better than that? To have a better bundle than that, Ryan? Exactly. Because it would have to, if she were to be better off than at that point X, she would have to be on a higher indifference curve. Any indifference curve that is higher than that is outside the budget set. Okay? So that's how we know. That tangency means that's the last highest indifference curve that she can get on without completely leaving the budget line. If she were to move any higher on an indifference curve, that would be outside the budget. So that is the maximizing point. That X is the optimal choice. And that, I would like you to appreciate that means you now have a model of the consumer, right? Now you can model the goal-oriented behavior through preferences. Now you can model the constraint through the budget constraint. You put the two together, and you've got a model of optimal choice for the consumer. Yeah?
Could you say about the definition for the X again? I know what that means, but what you mean about that is the highest about the...
Okay, so let me say that again. That point X is optimal because at that point the indifference curve going through X is tangent to the budget line. And that means she could get on a higher indifference curve only if she left the budget.
Oh.
Okay? Okay. Yes, last question.
There are points on that curve that are above the...
like B. Yeah. Like B is above the budget set, right?
Right, but as long as so those aren't optimal because she can't afford it?
Exactly. So
it's touching, every single one of those points is optimal. Like it's not just X, it's as long as
only X is optimal. Only X is optimal for this consumer because she can afford it.
But what about like just below X, like before B?
She can't afford it.
Why not? It's almost.
There's only one. So maybe okay. So maybe you're criticizing my artwork. I think. I'm joking. I'm joking. There is only one point where they touch.
Oh, okay.
Okay. Yeah. Okay. Thank you. So I'll see some of you tomorrow. Some of you on Wednesday, on Thursday, and we'll do some exercises that will let you practice this stuff.
Nice, good job.